Welcome back to our series on linear graphs. In this video, we're going to look at finding the gradient. Just a reminder, our standard form for a linear graph is this equation here, y equals mx plus c, where m is our gradient or slope, c is our y-intercept. Now, our gradient can be either positive or negative, and it's helpful to think of this as going from left to right, like we're reading across the page. If, as we go across the page, it's going upwards, it's a positive gradient. If we go across the page and it's going downwards, it's a negative gradient. Now, to find the gradient from a line graph like this, we're going to look for the rise divided by the run. The rise is our change in the y, how far up it goes or how far down. Run is our x, how far across it goes. Now, we start by looking at our graph and drawing a really nice big right angle triangle. We don't pick a little bit like this. It's too hard to work out what our coordinates are. We look for points where it is clearly going through a nice whole number. So we're going to use this triangle here. We count how many units it goes up in the y direction. Here it is going up 4. We count the number of units in the x direction. Here it is 2. So our gradient is going to be 4 divided by 2. It's going to be 2. And we note that it's positive. It is going upwards. Let's practice a few. We draw in a nice big triangle going through clear intercepts. We calculate our rise. How many squares up is it going in the y direction? This is going to be 2. We find our run. For our big triangle, it is going across 6. So here, rise over run is 2 divided by 6 is a third. And we can see that this is quite a gentle slope. It's still positive because it is going upwards. This one, we notice straight away, it's going down. So it's going to be a negative. But we still do our calculation the same way. Draw our nice big triangle. In the y direction, it is going down by 6. So we write negative 6. X, it goes across by 4. So this is going to be negative 3 on 2, negative 1.5. Whichever way we want to write it, I will tend to stick with the improper fraction because it does make it easier to see what's happening with our gradient and to do our calculations. This formula is useful for later on if you have to find things like the formula for a line. It does look a little bit confusing, but all it is that we have one point here, the second point here. Those little subscripts don't mean squared or anything like that. They're talking about which point we are referring to. So This point here is going to be our first one, which means that this is x1. This will be y1. This is our second point. So this is going to be x2, y2. So all we're going to do is substitute those into our formula. x1 goes down the bottom. y1 goes on the top. x2 on the bottom, y2 on the top. So now we work it out. 5 minus 2 is 3. 3 minus 2 is 1. Our gradient here is 3. If we have negatives or zeros, we just have to remember to include those. So for this example here, m equals x1 is 0. Y1 here is negative 2. Now because we've got a negative and a negative, that's going to end up being a positive. We substitute in our second point. x2 is 4, y2 is 2. Now we've got 2 minus negative 2, which means it's 2 plus 2, it is a 4. 4 minus 0 is 4. 4 divided by 4 is 1. Thank you for watching, and we will have more videos coming up in a few weeks. Thank you.